So, use the quadratic formula to find the roots of f of x. Awesome. So remember the formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And again, here's a, b, and c, and we already did b squared minus 4ac. So we can just replace b squared minus 4ac with negative 4. So we gotta do that part. Now, you may not have heard negative b. You may have heard opposite b. Same thing. B is 2, so negative, or the opposite of b would be negative 2. Plus or minus the square root of negative 4. Just replacing that red with negative 4. All over 2 times 1. So pretend there is no negative there. What would be the square root of 4? 2. And then, since it is a negative, that's where the I comes in. So you treat it just like you always would, only it's going to be an I, because it's a negative. It's imaginary. Now, I can't just cancel those two. Can't do that. But what I can do is factor a 2. I'll factor a 2 out of the top, and I get negative 1 plus or minus I all over 2. That's why I factored out a positive 2, just so they would both be the same. Now the 2's cancel, so you get negative 1 plus or minus I. Those are 2 answers. It's negative 1 plus I and negative 1 minus I. I don't care which way you write it. It's 2 imaginary roots. So the next one says, since imaginary roots come from taking the square roots of negatives in the quadratic formula, what can be said about the possible number of imaginary roots of a polynomial function? Well, there's at least going to be 2 of them, if there's any. They always come in 2s, because it's plus or minus. So you've got negative 1 plus I and negative 1 minus I. So they have to be a factor of 2. Just like with the positives, we said, they always had to be 2 apart. Basically the same thing here. So I'm going to write it like this. Imaginary roots must occur in even amounts So, i.e., which means, for example, 4, 2, 0, imaginary roots. Now, we could have more if it was, a really big degree. But they have to occur in even amounts. Now, that wasn't true about the positive and negative. They just had to be 2 apart. So you could have 5 negative zeros or 5 positive zeros. It was just 5 or 3 or 1 that had to be 2 apart. But with imaginary numbers, they have to be in groups of 2. So they have to be even. 0, 2, 4, 6, 8. They have to come like that because they come from the quadratic formula. And that plus or minus means it has to be that way. Okay, so for the function blah, what are the possible numbers of imaginary roots? Well, since the degree is 4, we could possibly have 4 imaginary roots, or 2, or 0. And the 4 came from the degree. Now, if the degree had been 5, the answer would be the same here. It would be 4, or 2, or 0. Because you can't have an odd number of imaginary roots. So we've gathered all that information, it says. We're going to draw a table below that summarizes the possibilities of the types of roots for, it says h of x, it's p of x that we've been doing. I don't know why it says h of x. Then graph the function on the calculator and put a star by the combination that is correct. Okay, so we have positive roots, negative roots, zeros, and imaginary. I'm going to leave a little spot up at the top, sorry. Positive, negative, 0, or imaginary. Now we figured out, if you go back, yeah, we did this yesterday. Remember, to figure out the positive and negative roots, we just look at the sign changes of p of x and p of negative x. And we found that there were 2 or 0 positive roots or 2 or 0 negative roots. So 2 or 0, 2 or 0. And we also just did this too with p of x. How many roots are 0? So we just, how many? None. Because it ends in a constant. Remember, it has to end with an x, basically. You can't have a constant term. So there's 0 of those. That makes it easy. And then the number of imaginary roots, well, we just figured that out. It's 4, 2, or 0. Okay, so we could have 2 or 0 positives. Okay, and with those 2 or 0 positives, we'll think about it this way. With the negatives, it could also be 2 or 0, so we're going to put 2 for each of those first. And then 2 or 0 again, and we'll put zeros for each of those. We're trying out all the possibilities. So we could have 2 positive and 2 negatives. Or we could have no positives and 2 negatives. Or we could have 2 positives and no negatives. Or 0 positives and 0 negatives. So basically all the combinations. The zeros are easy enough. 0 is 0 all the way through because of that. And then for the imaginary, we just have to figure out what's left. We know that all these numbers have to add up to equal 4. So if you have 2 positives and 2 negatives, then you can't have any imaginary. Because that's all 4 zeros. If you have just 2 negatives, then 2 of them had to be positive. If we had just 2 positives, then 2 of them had to be, I said positive, didn't I? Imaginary. And then what about the last one? 4. Yeah, if you have no positive and no negatives, then all 4 of them must be imaginary. So this is a picture of all the possibilities. And we're going to see which one is right by graphing it. So if you go ahead and grab your calculator or get it out of your backpack if you're using your own. And in our y equals, we're going to graph